Now, today we are going to start with the module 5, which is material science. The concept what we are dealing is classical free electron theory, that is CFET. What is CFET? Before we start with classical free electron theory, we need to go through with some of the definitions. Free electron concept. All metal atoms consist of valence electrons. These valence electrons are responsible for the electrical conduction in bulk state of a metal. What is mean free path, which is denoted by lambda? It is the average distance travelled by the conduction electrons between two successive collisions with the lattice ions. That means between the two successive collisions, what is the average distance travelled by an electron is defined as mean free path, denoted by lambda. Next is mean collision time, denoted by tau. The average time taken between two successive collisions of an electron with the lattice point is called mean collision time. Next is drift velocity. The net displacement is the position of the electron per unit time in the presence of electric field is known as a drift velocity. That means net displacement in the position of electrons per unit time in the presence of electric field is known as a drift velocity. Vd is denoted by E by m into tau, where small e is the charge of electron, capital E is the intensity of the electric field or the electric intensity, and tau is the mean collision time, and m is the mass of electron. Now, who has given this classical free electron theory? Drude and Lorentz theory in 1900, they have given the classical free electron assumptions, and we will look into it. What are the assumptions? These two scientists, that is Drude and Lorentz, combinedly they have given they assumed some of the things, and based on which they could explain electric field or the movement of electrons in the presence of electric field gives rise to the conductivity we are going to see. Freely moving valence electrons, called free electrons, in a metal are confined to its body, and electric current in a metal is due to the applied field as a consequence of drift velocity in the direction opposite to the direction of the field. That means when the electric field is being given, the electrons move in the direction opposite to that of electric field, because electrons are negatively charged, and the movement of electrons is mainly focused on free electrons. Freely moving valence electrons are called the free electrons, which cause the electric current in a metal due to the applied field. The free electrons are treated as equivalent to gas molecule and thus are assumed to obey classical free theory of gases in the absence of electric field. That means how a gas molecule, how the gas atoms will move, in the same way electrons are moving freely in all the directions in the absence of electric field. So they have said that the free electrons are treated as gas molecules and assumed to obey classical kinetic theory of gases. Vth is the thermal velocity, K is the Boltzmann constant, T is the temperature, and M is the mass. The third assumption is the electric potential due to ion cores is taken to be uniform throughout the metal. The attraction between the free electrons and the lattice ions and the repulsion between the electrons themselves are considered as insignificant. Now, relaxation time tau r. The time required for the average velocity of the conduction electrons to exponentially decay to 1 by e times its value just when electric field is turned off is called as relaxation time. Current density J is nothing but the current per unit area of cross section of imaginary plane held normal to the direction of the current in a current carrying conductor. That is, J is nothing but I by A, and we know that I is equal to N A E V D, and therefore J can be written as N E V D. Substituting the value of I and J is equal to I by A, so we get J is equal to N A V D. Next is electric field. The potential drop V per unit length of a conductor L gives the electric field that exists across a conductor of uniform cross section. that is E is equal to V by L. Now we see some of the terms here. Conductivity sigma, which is nothing but it is a physical property that characterizes the conducting ability of a material. It is inverse of resistivity. The conductivity means the flow of electrons, and resistivity means it is opposite to that of conductivity. That is, conductivity and resistivity are inversely proportional. That is, sigma is equal to 1 by rho, that can be written as L by RA, as rho can be written as RA by L. Electrical conductivity in metal, sigma is given by current density per unit electric field. So putting the values of J is equal to NeVd and E values, you are getting sigma is equal to Ne square tau by M. Mobility of electrons. The mobility of electrons is defined as a magnitude of drift velocity acquired by electrons in the unit field. Mu is equal to Vd by E, or mu is equal to sigma by Ne. Now let us see the failures of CFET. The Drude and Lawrence could explain successfully some of the factors, but there are some failures of CFET. To certain level, the successfully Drude and Lawrence could explain based on this classical free electron theory, but three things have been failed, so they are termed as failures of CFET. What exactly CFET says is how the conductivity is happening in conductors, that is in metals. What is the cause of conductivity, and it was explained to a certain extent by classical free electron theory. But there are some failures. We will see what are the failures. Specific heat. That means classical free electron theory could not explain the specific heat. Theoretically, CV is equal to 3 by 2 R. But the experimental value of specific heat was found to be CV is equal to 10 to the power of minus 4 RT, which is far lower than the expected value, and also showed a dependence of temperature which is contrary to the theory. So if you look at the theoretical value here, according to theoretical value, that is classical free electron theory, CV is given by 3 by 2 R. But experimentally it was proved that CV is equal to 10 to the power of minus 4 RT. If you look at these two, theoretical value and experimental value, in the experimental value, CV depends upon the temperature, but that could not be explained theoretically. And also, the values of both theoretical and experimental values there is a large variation. So, this theory could not explain the specific heat. Next is temperature dependence of electrical conductivity. It was experimentally observed that for metals, the electrical conductivity is inversely proportional to temperature. That means, electrical conductivity, experimentally it was inversely proportional to 1 by T. According to main assumptions of CFET, 3 by 2 kT is equal to half m Vth square. Vth is thermal velocity, K is the Boltzmann constant. We have taken the assumption that free electrons obeys kinetic theory of gas equation. From this equation, since electron obeys kinetic theory of gas equation, we are rearranging the terms, and therefore Vth is equal to root of 3 kT by m. From this equation, we can say that Vth is directly proportional to root T, where T is the temperature, because both are in the numerators. The mean collision time tau is inversely proportional to the thermal velocity. Therefore, tau is proportional to 1 by Vth, or tau is proportional to 1 by root T. How you have got root T here? Because in the above equation, Vth is proportional to root T. So instead of Vth, we are writing Vth value as root T. So tau is inversely proportional to root T. Now so this is the tau relation. Tau is inversely proportional to root T. Electrical conductivity sigma is given by, we already given before, sigma is equal to Ne square tau by M. Therefore, both are in the numerator. So sigma is proportional to tau, and we know that tau is proportional to root T. Therefore, sigma theoretical is proportional to 1 by root T. This is theoretically obtained. The prediction of CFET is not in agreement with the experimental value, because in experimental values, we have seen in the previous slide that sigma experimental is proportional to 1 by T, but what theoretically is, sigma theoretical is proportional to 1 by root T. So there is a difference of root, so this theory could not explain. Next is dependence of electrical conductivity on electron concentration. According to classical theory, electrical conductivity sigma is given by sigma is equal to n e square tau by m. From here we can say that sigma is proportional to n. This means that divalent and trivalent metals with larger concentration of electrons should possess much higher electrical conductivity than monovalent metals, which is contradiction to the observed fact. Experimentally, it is found that conductivity of monovalent metals, copper, silver, is greater than that of divalent and trivalent metals like zinc and aluminium. What exactly it means here is, we know that sigma is proportional to n. Now, according to this equation, the more the value of n, more should be the conductivity. But here, the monovalent metals like copper is more conductive than that of divalent or trivalent atoms. Experimentally, it was proved that copper is more conducting than zinc or aluminium, which are having zinc as 2 and aluminium as 3 plus. So, but here, as per the equation, n should be greater, sigma should be greater for greater values of n. Zinc and aluminium have greater value, but the conductivity of copper is greater than that of zinc and aluminium. So, this theory could not explain. So, this was a failure. So, CFET failed to explain these concepts. Thank you.